Why is China trying to reach Earth's core? That is the headline version. It sounds like a science fiction question. A country drilling through the crust, trying to punch into the hidden engine of the planet. But the real story is stranger, because China is not close to the core. No one is. The Earth's core begins roughly 2,900 kilometers below the surface. China's most public deep drilling milestone is around 10.9 kilometers. That sounds tiny. Until you remember that the deepest hole ever drilled by humans, the Soviet Kola superdeep borehole, stopped at just over 12 kilometers. Not because the engineers got bored, but because the Earth became too hot, too unstable, and too hostile for the tools. So why would China spend years pushing a drill into the desert, through layers of rock, hundreds of millions of years old? The simple answer is oil and gas. The more interesting answer is that China is trying to learn how to read the Earth before anyone else does. In the Tarim Basin, beneath the Taklamakan Desert, China has been drilling ultra-deep wells into some of the most difficult geology on the planet. One of those wells, Shendi Take 1, was reported at 10,910 meters deep. It passed through more than a dozen rock formations. It required more than 1,000 drill pipes and repeated bit changes. The final stretch alone took months, because at that depth every meter becomes a negotiation with pressure, heat and rock. Public reports describe the project as scientific exploration and energy exploration at the same time. That overlap matters. To the public, a borehole is a hole. To a government, it is a sensor. It tells you where ancient fluids moved. It tells you how rock stores hydrocarbons. It tells you how heat travels. It tells you which formations can break, which ones can seal, and where deep reservoirs might still be hiding. For China, that matters because energy is not just an industry. It is a strategic vulnerability. China imports enormous amounts of oil. Much of it moves by sea. Sea lanes can be monitored, pressured, blocked, or turned into leverage. So every barrel found under Chinese territory is more than a barrel. It is a little less dependence on routes controlled by other powers. That is the first reason to drill deep, but it is not the only one. China is also building the machinery of a new frontier. Ultra-deep drilling requires tools that can survive heat, pressure, vibration, chemical attack, and distance. Normal electronics fail. Normal drilling fluids break down. Normal assumptions about rock stop working. If a country learns to operate there, it gains more than a well. It gains high-temperature sensors, better logging tools, automated rigs, stronger drill bits, and new ways to model the subsurface. Those technologies do not stay in one industry. They matter for geothermal energy. They matter for carbon storage. They matter for mining. They matter for earthquake science. They matter for ocean drilling. They matter for anything that depends on knowing what is under your feet. And that is where the story moves from the desert to the ocean. China's deep ocean drilling vessel Meng Xiang entered service with a mission that sounds even more ambitious, to explore deep under the seabed, toward the moho, the boundary between Earth's crust and mantle. Again, this is not the core, but it is still one of the great prizes in Earth science. The mantle is not a giant underground lava ocean. Most of it is solid rock under extreme pressure and temperature. But over geological time, it moves, it carries heat. It drives plate tectonics, it stores water, carbon, and chemical clues about how the planet works. If you can drill closer to that boundary, sample it, measure it, and model it, you begin to turn the planet from a mystery into an instrument. That is what makes this more than a drilling story. It is a measurement race. Here is the scale that matters. A normal oil and gas well is often a few kilometers deep. Some go deeper, but ordinary industrial drilling still lives in the world of single-digit kilometers. The deepest human borehole ever made, the Soviet Kola superdeep borehole, reached just over 12 kilometers. China's public ultra-deep milestone is in that same extreme neighborhood, with Shendi Take 1 reported at 10,910 meters. So the question is not only whether China can reach the ultra-deep zone, the question is whether they stop there. Because if the next target becomes 30 kilometers, then 50, then 100, then 200, then 1,000, the story changes at every step. Each number is not just deeper. Each number is a different Earth. Now imagine what happens if the depth keeps increasing. At 30 kilometers, you are not near the core. You are still in the crust in many places, or approaching the deepest parts of it. But the conditions are already brutal. Temperatures can reach hundreds of degrees Celsius. Pressure crushes the borehole from every side. Electronics become fragile. Drilling fluid chemistry becomes a survival problem. The rock is no longer just something you cut. It is something that pushes back. At 40 or 50 kilometers, depending on where you are, you may be approaching the moho, the boundary between crust and mantle. This is where the public imagination often gets it wrong. You would not suddenly open a bright orange sea of lava. The mantle is mostly solid, but it is hot, dense, and strange. Over long time scales, it behaves less like a wall and more like something that can deform. That is a different kind of enemy. A normal hole wants to stay a hole. A hole at those depths wants to disappear. At 100 kilometers, the word drilling starts to break. You are in upper mantle territory. Temperatures may be around 1,000 degrees Celsius or higher. Pressure is measured in tens of thousands of atmospheres. Rock can still be solid, but not solid in the comforting way we know at the surface. It can creep, it can deform, it can close around any empty space you create. So the question is no longer, can you make a drill bit hard enough? The question is, can you keep geometry alive inside the Earth? At 200 kilometers, the prize becomes even stranger. You are in the region where deep carbon cycles, water locked inside minerals, and mantle chemistry become part of the story. This is the world that helps feed volcanoes, diamonds, deep fluids, and the slow circulation of the planet. But engineering an open borehole there is almost impossible with current technology. At 1,000 kilometers, you are still not at the core. That is the scale shock. 1,000 kilometers down would be one of the greatest technical achievements in human history. It would open direct access to a part of the Earth we currently understand, mostly through seismic waves and laboratory simulations. But the core boundary would still be nearly 2,000 kilometers deeper. So if China says deep Earth, the real question is not whether they are about to reach the core. The real question is what they learn on the way down. That is also why other countries would worry. Can America or the rest of the world stop China from drilling? Not directly. If the drilling is on Chinese territory, no foreign country can simply switch off the rig. If the drilling is done by a Chinese vessel in permitted waters, the same problem applies. The hole itself is hard to stop. The supply chain is easier. Ultra-deep drilling depends on specialized technology, high-temperature electronics, drilling bits, measurement while drilling tools, logging systems, pressure-resistant sensors, and advanced drilling fluids. A rival can restrict exports. It can pressure companies. It can limit university partnerships. It can slow the flow of data from international scientific drilling programs. In the ocean, the pressure points are different. If deep drilling enters contested waters, environmental review, maritime law, military suspicion, and diplomatic pressure all become tools. A research vessel can become a geopolitical object. A seabed sample can become a strategic asset. But the most important response may not be stopping China. It may be racing China. The country that learns to drill deeper, measure better, and model faster gains a new kind of map. Not a map of borders, a map of pressure, heat, fluids, faults, reservoirs, and hidden structures. That map has economic value, it has scientific value, and it has strategic value. This is why the phrase Earth's core is useful, even when it is technically wrong. It captures the fear that something private is being opened, that a nation is trying to reach beneath the visible world, beneath cities, oceans, mountains, and borders, into the machinery that makes the surface possible. But the truth is more subtle. China does not need to reach the core for this to matter. At 10 kilometers, it learns how to drill hotter and deeper than most countries can operate. At 30 kilometers, it would begin testing the limits of crustal engineering. At 50 kilometers, it would be knocking on one of geology's most important boundaries. At 100 kilometers, it would be fighting the physical behavior of the mantle itself. At 200 kilometers, it would be touching the deep chemical memory of the planet. And at 1,000 kilometers, it would still be far from the core, but close to something just as powerful, direct knowledge of a part of Earth that has always been hidden. That is the real story. The danger is not that China opens the Earth. The danger, if you want to call it that, is that China learns how to read it.